Guys, we have this question right here. It's asking determine the reaction on and the force in each member of the truss and state if the members are in the tension or compression. Also they have given this theta is equal to 30 degree. Now we have to find each of the members. So we have to find DC, we have to find BC, we have to find DB, and we have to find AD, we have to find AB. So let's do one by one. So first of all, I would like to take the entire truss and solve whatever we can first. So here we are going to have an AY, we are going to have an AX right here, then also we are going to have a C acting on this one. It's going to be exactly perpendicular to this line, so this is going to be my C. So in this case what's going to happen is if a force acting on this side, it means we have two different forces, like there's going to be a CX acting on this side and CY is going to be acting on this side. That's what it literally means. And then we know this is a 90 degree, so let's show in a different color. So this is going to be my 90 degree, right? So since this is my 90 degree and I know this is making 30 degree with this one, so first of all it's better to take the angles first to avoid confusions. So we have 30 degree, so since this is 90 degree, if it's 30 degree, this is going to be 60 degree, right? 60 degree. And if I extend this line right here and make a triangle right here, it's going to be, this is going to be 90, then this C shape. So if this is 60, this is going to be 60, therefore this is going to be 30, and that is making it the CY. So let's be clear about this. Is clear right now. Then we have AX, AY, and CY, CX, and this is going to be C. So let's see what we can find. If I take moment around A, what will happen? So we have CX, CY, and we have these numbers. So this CX will automatically cancel because it's along the axis, right? So CX will cancel. We can find CY. So it's better if we take a moment around A, these all two will be eliminated, so we can find CY, right? So let's do that. So first approach moment around A is equal to 0 in statics. If I take counterclockwise positive and solve for this one, it's going to be 3 times. This is pushing this object clockwise, and it's going to be 3 times the height, negative 3 times. Negative 3 times the height is 1.5. Then we have 4 kilonewton pushing this object down. It's going to be negative 4 times 2. Then we have Cy pulling this object up. This is going to be positive Cy times 4. So these are the three things we have equal to 0. Now if I solve for Cy, it's going to be 4 Cy is going to be equal to this is going to be 4.5, 8 plus 4.5, 12.5. Cy is going to be equal to 12.5 divided by 4, which is equal to, so 12.5 divided by 4. Let me calculate this. 12.5 divided by 4 equal to 3.125. Cy is equal to 3.125 kilonewton, and we know the direction is right because the answer is coming positive. So this is the direction. So if this is the direction, Cx is going to be this direction. Since we found the Cy, now if I find the vertical components, I can find the Ay. So let's take the sigma Fy is equal to 0 in statics. If I take upper side positive and solve this one. AY is in the positive direction, and minus 4 plus CY is equal to 0. We know CY already is 3.125 and AY is minus 4, so it's gonna be AY minus uh, minus 0.875 equal to 0, so therefore AY is going to be equal to 0.875, and our direction is right because the answer is coming positive. Then what we can find from CY, I can calculate C using this angle. We know this is 30 degree, so I can use that angle to find C. So C is going to be CY cos 30. Cos 30 is equal to C. So if I calculate CY, we know this CY already 3.125, 3.125 cos 30, which is going to be equal to, um, let me calculate, 3.1, 3.125 cos 30 is equal to 2.70. So this is 2.70 kilonewton. So C is equal to 2.70 kilonewton. Therefore, I can find Cx. Cx is going to be C cos 30, right? Cos 60, this angle. So it's going to be Cx is going to be equal to C cos 60. So we know C is 2.70, cos 60 is half, and this is going to be 1.35 kilonewton. Now let's see what we can find. So we know AY right here, we know CY right here, and we know CX right here. So if I know Cx, I can find the Ax by taking the summation of horizontal forces. So if I take horizontal forces equal to 0 in statics, if I take this direction positive and solve for this one, I would take Ax is in positive direction and 3 is in the positive direction, and we have Cx in the negative direction, and that's all we have. So if I solve for it is equal to 0, so if I solve for this one, Ax is going to be equal to 3 minus 1.35 is equal to 0, and Ax is minus, it's plus 1.35 is going to be 3 minus 1.35 equal to 1.65. So it's going to be 1.65 is equal to 0, and this answer comes to be negative. Therefore we know our direction is wrong. This is going to be opposite direction, this direction. So this is going to be 1.65 kilonewton in this direction. So that's all we know. What else we can find from these things? That's all we can find from the outer surface. So let's go for one by one. So since we had to pick a pin that has two unknown, right? So first pin, we know AY, we know AX, we had to find AD, we had to find AB. But the second pin looks much easier. I I take this one B. So there are some direct answers right there. For example, if you take pin B, there's a BD acting. We don't know in which direction. I just assume this is the direction, and this BD, and there's a 4 kilonewton acting on it. And then we have BC, we don't know the direction, we can just assume this is the direction. And then here we have AB, and if I solve for this one, like for this one I can find the BD directly because we have two vertical components and one is known, so I can find the BD directly. So sigma Fi is equal to 0 in statics. If I take the upper direction positive and solve for this one, this is going to be BD minus 4 is equal to 0. So BD is going to be equal to 4 kilonewton. And since the answer is positive, we know the direction is right, therefore this is a tension, because if you see something going away from this pin joint, this means it's in tension. And then what we can do is, let's see what else we have with two unknown. So we have a by a with two unknowns. Let's pick the a for a and solve it. AD right here, we have AB right here. Also we have AY acting on upside, and we have AX acting on this direction. So we know AY, we know this one, we know AX, we don't know AB, we don't know AD. So since if I take horizontal forces, how many unknown we have? We have AX unknown, AB unknown, AD unknown. But if I take vertical forces, how many unknown we have? AD is the only unknown if I take vertical forces. So let's take the vertical forces we have. So sigma Fi is equal to 0. In statics, if I take upper direction positive and solve for this one, it's going to be plus AY, and this is also plus AD. Let's say this is a theta. No, don't confuse with the theta. Let's take the alpha. So if this is alpha, this is going to give us, so since this is vertical, this is going to be sine alpha, AD sine alpha is equal to 0. AY, we know this already, it's going to be 0.875, and AD sine alpha, to sine alpha I can use opposite over adjacent, so opposite over hypotenuse. We know opposite is 1.5. We can find hypotenuse using Pythagorean theorem. So if I find using Pythagorean theorem, this is going to be 2 square plus 1.5 square root. So this is going to be my hypotenuse. So if I find, I will get 2.5. So let's apply here. So it's going to be sine alpha is going to be opposite over hypotenuse. So it's going to be 1.5 over 2.5 equal to 0. So I can bring the 0.75 to the other side. It's going to be AD times 1.5 over 2.5 equal to minus 0.875, and if I calculate AD, comes out to be 1.46 negative. Therefore we know the answer the direction is opposite, so it's going to be AD 1.46 compression, because if this is going to be my direction, right? If this is the direction, then this is acting toward the pin joint, so this we know it's a compression. So from this information, AD, we have AD right here. Now I can find AB using this one, because we know AX, we know AD. Now I can find AB by taking the horizontal components of this one. Let's take the horizontal components. Let's say sigma fx is equal to 0 in statics. If I take this direction positive and solve for the horizontal forces, it's going to be ax negative ax, and then we have positive ab, and negative ad is going to be cos theta, cos alpha, ad cos alpha equal to 0. We know ax already, it's 1.65, so we have to put negative 1.65. Then we have AB. Did we find AB? That's what we have to find. So AB and AD we have right here. It's going to be minus AD 1.46. Cos alpha is going to be cos mean adjacent over hypotenuse. So 2 over 2.5 equal to 0. And if I solve for this one, I will get AB is equal to, let me see what I get. So 1.46 times 2 over 2.5 minus 1.65 equal to so this is this comes out to be, wait a minute, I'll calculate again to make sure. So 1.46 times 2 divided by 2.5 plus, right, plus 1.65, which is equal to 2.818. So this total gonna be 2 point minus 2.818 equal to 0. So AB comes out to be 2.818 positive. So we know that our direction is right. Therefore, this is the direction. So this going away from the pin joint is tension. This kilonewton. This is going to be in tension. Though all are kilonewton, right? In tension. That's the answer for AB. So we have found AB. We have found AD. We have found BB. Now we have CB and CD left. So to find that one, I can find the CB using this one right here, because we know the AB right now, so we can find the CB. So let's take the moment around x sigma fx here. If I take this direction positive, minus AB plus BC is going to be equal to 0. So minus 2.818 plus BC is going to be equal to 0. Therefore, we know BC is going to be equal to 2.818, and since the answer is positive, we know this is also in tension, and that's my final answer. And we have found BC. Now we have to find BC. We can take D, pin joint D, or we can take pin joint C, whatever you want. So let's take the D. So if I take the D, we have a 3 kilonewton acting on it, and we have BD acting downside. Or is it, yeah, this in tension, so it's acting downside. Then we have AD. AD is compression, so it's going to be this side. Then we have CD. CD, that's what we have to find. So let's assume this is the direction. CD and 3 kilonewton. This is dB. This is going to be AD. So that's all we have. We can take vertical component or horizontal component to find this one. Let's take the horizontal component and see what we get. So sigma fx is 0 in statics. Actually, yeah. Let's take the horizontal components. Sigma fx is 0 in statics. Then AD is going to be plus AD, and this is going to be AD's. Okay, wait a minute. Okay, this is the alpha, then this is going to be alpha 2. Okay, so AD cos alpha and then we have CD. So CD is going to be, so this is also alpha because same height and the same distance. So this is going to be alpha 2. Therefore we can say this is CD cos alpha, and that's going to be positive. Then we have 3 kilonewton acting in the positive direction, so it's going to be 3 kilonewton equal to 0. So we know AD already, 1.46 multiplied by cos alpha. So cos alpha means adjacent over hypotenuse. We found hypotenuse 2.5, so 2 over 2.5 plus CD. We know it's CD, that's what we have to find. So CD cos alpha is going to remain same, and plus 3 CD cos alpha is equal to minus 3 minus, so if I calculate 1.46 times 2 divided by 2.5, 2.5 is equal to 1.6168, so it's going to be minus 3 minus 1.168, so it's going to be minus 4.168. Now I had to find CD, so this is going to be CD cos alpha means CD times 2 over 2.5, so CD is going to be equal to minus 4.168 multiplied by 2.5 and divided by 2. So if we calculate this one, 4.16 multiplied by 2.5 and divided by 2 is equal to 5.2, and the answer is negative. Therefore we know well, we know this is going to be opposite direction. So this direction we took CD, so we took this direction. The answer is opposite direction, so we know this is in compression. Therefore we know CD is equal to 5.2 kilonewton compression. So that's all we have to find. We have found AD, AB, BD, we have found CD right now, then we have found BC. That's all we have to find. Determine each the reaction force in each members of the truss, state if the members are in tension or compression. That's all we have to find. I hope you guys like this video. See you next time.